Fine. And so what we're trying to do is to improve our long-term speed, not our short-term speed. We have this obsession with short-term speed, and that's not been helped by things, for example, in iterative development approaches, things like Scrum, that over time iterations have become shorter and shorter. Actually, that's increased our short-termism. Actually we care about the velocity of this, and as I said in the talk, most of the time it's not velocity, it's speed that people are talking about. Velocity is about direction, and to understand direction you need to slow down and sort of look around, like where are we, what direction are we heading, where should we be?
I've just been to your talk here at the Craft Conference, and I gotta tell you, I've seen so many talks by you, like at NDC and now here at Craft, and also a bunch of them on YouTube. So I'm in kind of trouble. What should I ask you about? Because you talk about so many things.
I talk about so many things. What should you ask me about? I don't know.
But
you can ask me about the weather, because I come from Britain and we always talk about the weather. The weather here is beautiful. I'm absolutely loving that. But so there's that. Kevin, do you like the weather? It's like, it's great.
Okay. So you like the weather here?
I think the weather is absolutely lovely. I love coming to Budapest in the summer. In summer months, I've been.
Okay. Have you ever been to Budapest?
I have, yes. I come here a couple of times a year. I do some software architecture workshops for a company. So that brings me through all the seasons, and obviously summer is going to be my most favourite. You guys have cold winters. I'm not so keen on those, but the summers are beautiful. Walking by the Danube, it's great.
Yeah. So you like Budapest? That's nice.
I do, yes.
But you have also talked about removing code.
Yeah.
And since that's the talk you just gave, maybe we can talk about that.
Let's start with that. That's the easiest thing. Yeah, so the talk was decremental development. It's a phrase I coined a few years ago because whilst we're also moving people into incremental development, the idea that we should build up and build a system or grow it rather than just sort of just add stuff arbitrarily, and also to avoid the idea of some grand master plan where it all comes together. It's like, no, you grow it gradually over time. So time matters. But the problem is that I think when people talk about incremental and iterative development, they only see the time box side of iteration rather than the idea of refinement. Iteration implies that you revisit. It's not just a process of time, it is a process to do with the thing you are building. So the idea is you refine it, and as you learn more over time, you realise that some parts of the code are not necessary, some parts are too complex, some parts are no longer relevant, because that's the thing, is that a lot of what people say is technical debt is not necessarily bad code, it is just code that was once good, but the world has moved. It's no longer relevant.
Necessary.
Yeah, it's either for business reasons or because the technology's changed. So, we find that if your system is something like 10 or more years old, just think of the difference in terms of processor performance or memory or network speed. And so many of the little workarounds, the clever things that you did, are no longer relevant. And so unfortunately, it's not just that they're no longer relevant, they still run. And they are actually having the opposite effect. Every time a developer goes to them, they have a complexity to them that is nothing to do with anything that the system does now, but you're still paying a tax, you're paying a cost for that complexity. So decremental development is this idea that as time goes on, you learn more about what it is you're trying to build, how you're trying to build it, you understand more about how the context changes, and so there's this idea of you want to reflect that, because otherwise your system will end up being just a big pile of first drafts. It's the first idea we had. Okay, let's add that, and that becomes a problem, and therefore all the work on the system is now about fighting this. So we find so many. I used a couple of examples where people had ended up with systems. I cited Facebook's iOS app from a few years ago. The iOS app had 18,000 classes. I mean, that's ridiculous. What's it doing? 18,000 classes. I mean, maybe 18,000 lines would be plausible, but 18,000 classes, it is now feeding off itself. But at any given point, there's over 400 developers on it.
Yeah.
And there's points you can't create a small system with that. So
it's accidental complexity.
Exactly, yeah. And we end up spending most of our time, and Fred Brooks, in his No Silver Bullet and sort of Essence of Accident and Complexity writings in the 1980s, he very strongly focused on this idea of and he asked the question, how much of what developers do now is to do with accidental complexity rather than the essential, the nature of the problem, the actual reason the system exists, the reason a system does not exist to fight its own technical debt. But that's how we staff systems, that's how we price systems, and then we size the systems. We end up with too many developers. Why do we have so many developers? Because we've got so much code. And then you start saying things, you say, oh, well, there's a simple way of doing this. Oh, yeah, but that's for simple systems. And it's just like, well, your system is a simple system, or rather, it could be. Inside it, there's a simple system trying to get out, but it's now become buried, and so you find people dealing with hundreds of thousands where they should be dealing with tens of thousands of lines. You find people dealing with millions of lines where they should be dealing with hundreds of thousands. You find this notion of teams, we need to have a whole division dedicated to this product, and the teams are going to scatter across time zones. And you're looking at it going like, I could get a team of 12 people to do this in one place. And so the price, the cost, the human expense, the financial expense of not looking after your system. And we often talk about things like technical debt, but here my interest is much, much more direct. It's not just a technical debt question, it's actually you can reduce things that are known to work, and you now know a better way. It doesn't mean that there was debt there because it was done poorly and messily. It just means we can probably simplify. We have learned things.
Yeah, and one example of that I can think of off the top of my head is I had a project where the first iteration was we were running on Amazon instances, and we managed our own Docker containers and all that kind of stuff. Then we realized that we could move to Heroku, so now we don't have to manage the Docker containers, but we still have to manage scaling. So if there is a larger load, then we have to scale things up, scale things down when it's not necessary, and then now we are thinking of moving towards Lambda, Amazon Lambda, because then you don't even have to worry about scaling.
Yeah.
So and all the code that was dealing with the platform and then dealing with scaling the platform as a service is just useless after this, right?
That's right, and that's the thing, is to try and cut away as time goes by. Somebody else will provide, or you will provide, or you will realize something that simplifies it, and it means that a whole area of concern, and therefore an area of work, of bugs, of potential security issues, or whatever, now goes away. You want your software to be as close to the thing you're trying to do as possible, whereas we seem to put a lot of distance and complexity, and the architectures, the team structures begin feeding off themselves, and I don't think that is healthy. And we have examples, just whether it's dead code, irrelevant code, or whatever. These are all things that people are reluctant to remove because
we are hoarders.
We are hoarders, yeah.
We like hoarding code, right? So
I created it. I put my love, my life into it.
Exactly.
I'm not going to throw it away.
It's something that you build.
Yeah.
And also one other thing that ties in really nice with all that is today's morning keynote. Have you heard it? Unfortunately, no. I'm afraid not. I did want to attend, but I realised I needed to do some slide engineering. Yeah, everybody changes their slides in the last moment, right? So what that talk was about is partly it was about many things, but one of the key takeaways for me was that as you progress, first when you build something, it's a novelty. You have to custom build it because no one else has before you. Yeah. Right? And then many companies will build the same thing over and over again, because they all think that it's normal. But after a while, we realize that it's something that we could do more generally. And then someone writes a library, and then now it's just you just buy that library, or even just get it online for free because it's open source. And then after a while, it becomes a cloud service, and you no longer have to build that stuff.
Yeah.
So, and then you might want to get rid of all that code that used to be useful. But it's just replaceable with a commodity.
Yeah, so I think that commodification, that it's interesting because that's an observation that I first encountered many years ago, 2000. It was this idea that over time, if you like, it's like watching a pint of Guinness settle. You pour it and then it settles slowly. What you find is that over time, certain services, concepts, features, whatever, just gravitate downwards in the system in terms of the technology stack. So you no longer have to build those things. They're now part of the platform, or you're able to find a platform. It becomes commodified, and you can rely on that. And this idea is that your work can now be directed to somewhere else. And to hold on to that, whilst at one level it's a beautiful memory, it's not something you want in your current code base. And your version control and your older copies of the system are much better at remembering that. There's no need to keep that history current. It's not. Software is a conceptual, informational thing. So the idea is that we don't have a logistics. There's no issue of where do we put the rubbish. As we drive around, we can see buildings, and people have to put buildings up. People also have to destroy buildings. Destroying a building and taking it away is a very big task. In software, it's we're done. In other words, we don't have logistics. We don't have this weight of stuff.
And by the way, if you think about it, a building is usually dealt as an asset, right?
Yeah.
But code is not an asset.
Yeah, so I closed my talk with one of my favourite quotes, something that Kirk Pepperdine tweeted at me a few years ago. I can't remember the context of the conversation, but functionality is an asset, but code is a liability. And I find this is a provocative and counterintuitive way of looking at it, because I spent most of my career trying to convince people that code is an asset. In other words, please look after it. It's worth something. It has value. It's not just a thing that happens and the real business happens elsewhere. Your code is actually important, because without it, you're not going to get software. But what I like about this idea of code being a liability is that it also tells you why you want to care about your code. It also tells you why you want to minimize it. Because a liability is something that you wish to minimize. All businesses have assets and they have liabilities. You can't eliminate the liabilities, but what you do is you look to manage them. You manage them, you keep your eye on them, you don't let them go out of control. So therefore, when something is a liability, it means you pay attention to it. You understand it. You look to manage, reduce it. That is your goal. You wish to reduce that. And so there's this curious thing that although the code is the thing that enables the functionality, it is also the code that prevents you from changing the functionality.
Exactly.
It's the very thing that stands in your way, and in some systems it's worse than in others. There's more problem. You ask developers, what would you need to do? Can you imagine the changes you need to make for this user story? And they go, oh yeah, and I imagined it quickly. Now how long is that going to take you? Well, the time is going to be to do with dealing with code, and that code is going to be the obstacle between imagination and reality. So this idea. This is why we want to minimize it, because it has direct financial consequences, but also in terms of risk management. If you've got dead code, and I made a point in the talk, and I've done this in other talks, where I emphasize this idea of dead code, don't leave it around. It's not just lying there being harmless. If it is harmless, then you should be able to remove it. If you don't know that you can remove it, you've just learned something. You've learnt that you don't have full knowledge of your system, that you're unconfident, that it's actually not necessarily secure and accountable. So the idea is get rid of it, because otherwise you end up with a situation. I gave you an example. The Ariane 5 launcher exploded on the launch pad because of dead code from Ariane 4. It was no longer relevant, and it became zombie code. It came back to life. It caused behaviours that were not appropriate for that system, and ultimately led to the rocket's destruction. Knight Capital Group a few years back lost they lost themselves, literally. They lost nearly $500 million by the end of the day because of 45 minutes of automated trading that went wrong because of some dead code that came back to life. So the thing is, if it's dead, bury it, chop its head off, do whatever it is you want to do with zombies, okay? Just don't let them come back. So this idea is that you want to be focused on your code. And a lot of people feel frustrated because they're in a situation where they say, well, we can't do that because we don't know if the code is there. We don't know if this code is relevant. We don't have tests. And so you see this vicious cycle where all that's going to happen is that it will continue, and you're going to perpetually and gradually lose control of your ability to keep your code in the present. And that, I think, is the idea, is you want your code to be as close to your present understanding and the present desires of the customer. The more stuff, noise that you have, the further back in the past your code is effectively living. Your software is always behind the times. Well, there's a certain truth to that. The question is not whether it is, but how far back it is. And that becomes the issue.
Yeah, so actually that's one of the things why I really don't like old PHP code, because every file is an entry point, right? And you never know if that file is being called by some bookmark in someone else's browser.
Exactly.
Which is like the worst possible scenario, right?
Yeah.
It's the kind of death code that if you can never delete it, because you never know that one of your customers have decided that this is a backdoor for them that they can use.
That's right, yeah.
Via an API, like an API.
Yeah.
That actually happened to me. We have removed a file that we thought was dead code. Nothing referred to it, and it turned out that it was something that was meant to be decommissioned years ago. But one of the customers has used something that was, mind you, designed for use by humans, right? So it was a website that had a post that could handle post requests.
Yeah.
And it was meant to be used by humans, but they actually built another service around it that they used it as an API, which is like the worst thing you can do. Like, never use UI and it's an API.
Yeah.
But they did that.
Yeah. There's a couple of things that I think come out of that. One of them is this question of dependency management, and I think sometimes we are very careless with the dependencies. You want to manage your dependencies, because if you don't, then there's all kinds of fun that can happen with that. And I'm thinking things like the left pad incident, that you have problems with that. But also there's this idea that Martin Fowler talks about a lot, about this idea of the difference between a public versus a published API. The idea that offering an interface, we need to be very careful to hold back what we offer and almost be reluctant to offer certain interfaces. But also, there's another area here that we see that ties back to something I was talking about earlier, which is about knowledge. A lot of software development is about knowledge, and we need to know. We don't want ignorance about our code base, but also we don't want ignorance about how our systems are used. There is this idea of in many cases we are accidentally operating in the dark. We can't change that because we don't know. That's so often the case. Yeah. So it turns out we have a knowledge gap in many cases. Sometimes that can be addressed. The knowledge of our system on the inside is something we shouldn't let go of. We should treat that. That is an asset. That allows us to actually manage the code. But also what we offer to other people. We need to have a clear idea who's using our system, in what way, and how is that being used. Can we monitor that? And this is a much bigger philosophy than just simply offering a service. It is about having a deeper knowledge of who and how our system is used. In other words, the context in which the system is deployed. And context is everything. Once you understand the context, that sometimes allows you to say we no longer need this, or we have a better solution, or actually nobody's using this, and to really understand, as you say, using a UI and as an API is really, find out how people are using this stuff. We don't have that as a philosophy in many systems. So it's this idea of a knowledge flow is that it needs to be managed, and that seems to be a little outside of the concerns of functionality, because it's not actually functionality, it's outside the functionality.
So we talked about removing code, but it's not just about code, right? Because
No.
it's just one installment of the same concept, that you really should think about the things that you do or the things that you have, and consider the costs of doing things, and make sure that it's worth doing it.
Yeah, and in fact, there's this, picking up on your word consideration, to consider things. There is an idea that I was talking about, I found myself talking a lot about recently, of slowing down. And there is this idea of people are always in a rush. They're always, it's about speed. We've got to go faster. We've got a deadline. We've got this. We need to get more releases. We need to do. And when you come along and say you need to slow down, it's like, we don't have time to slow down. It's like, well, actually, that might be the problem. You're squandering your time. You're not making the best use of it, because it turns out that what we do when we are in a rush is we add stuff. We add stuff that we don't need. We don't contemplate. We don't try and say, actually, what is going on here? What is the understanding? Are we solving the right problem? Are we directing our effort into the right places? But also to the opportunity to look, whether we're looking at the world of the customer, whether we're looking at the world of technology, to look at something and go, there's a question here I had. We could do this, but is that the right thing? Could we save ourselves effort by not doing it, or actually spending a bit of time asking questions, or doing something regarding it as an experiment, offering it and saying, this is not permanent. It's an idea. Let's explore that. But fully with that idea that it's a learning exercise. We're probing, we're testing the world, and we're just trying to find stuff out. I mean, it's not permanent. We're happy to pull it back. So, in other words, that idea is that the code, in that sense, is temporary, but not temporary messy. We discovered that temporary messy lasts a long time and creates its own mess. But the idea that we are offering something as a thought experiment, quite literally a thought experiment, because this is all about our knowledge, our thinking. We're not sure. Fine. And so what we're trying to do is to improve our long-term speed, not our short-term speed. We have this obsession with short-term speed, and that's not been helped by things, for example, in iterative development approaches, things like Scrum, that over time iterations have become shorter and shorter. Actually, that's increased our short-termism. That actually we care about the velocity of this, and as I said in the talk, most of the time it's not velocity, it's speed that people are talking about. Velocity is about direction, and to understand direction you need to slow down and sort of look around, like where are we, what direction are we heading, where should we be, what do we do to get there, are we actually building the right thing in the right way, how have we engaged with the customer. These are all questions, they're not things about speed. And you can find that you are spending a lot of time speeding in the wrong direction, or inefficiently in the wrong direction. So this is for me the essence. Part of this kind of decremental approach is getting rid of stuff that is already there, streamlining it. But the other part is to say sometimes we don't need to have most of that there at all. If we just slow down and ask questions, and sometimes the question is code, sometimes the question is verbal, and that's fine, but to regard this as an ongoing process. Learning is an ongoing process. Knowledge acquisition, knowledge retention.
I really like that you said that you prefer the word learning instead of checking.
Well, no, that was study, yes, because I talked about PDSA, plan, do, study, act, the Deming-Shewhart cycle, and I said that. And many people know it's PDCA, plan, do, check, act. And I said, actually, I'm very fond of using PDSA, the original formulation, because study sounds slower than check. And so it should. If you check something, that's quick, it's cursory, it's just, But study sounds slow. And that's why I like it, because it's telling you that the doing was not everything. You need to look at what you've done, look at the world, try and understand it, seek explanations, look for other things you could try, and it's a much slower process. And this idea is you will head in the right direction. Instead of 120 kilometers per hour in the wrong direction, you end up walking 4 kilometers per hour in the right direction. You will get there faster. And it's as simple as that. This is this idea, and there is actually an idea in the Agile Manifesto, a very often overlooked idea, is that one of the things you're trying to do is maximise the amount of work not done. You know, it's not about the busyness. It's you're looking to improve your intelligence, and importantly, that's a point about collective intelligence. Software development is typically a team sport.
Yeah.
And what you're trying to do when we say team is not the individual intelligence added together. It's you're looking for our collective intelligence. The code base reflects that. You know, your workspace reflects that. The conversations you have transmit and reflect that. And the nature of the team will be reflected in the code base. And if you've got a lot of people that are very busy and don't talk to each other, you're going to get a lot of code that doesn't really quite fit and doesn't do quite the right thing, and will run up your technical debt. If you have a group of people who talk to each other and are happy to change their minds and revise their opinion in the light of new knowledge, then you're going to end up with a much more streamlined, a much sharper system. So there's this idea of recognizing, although it sounds initially, I'm just obsessed with the code, it's not that. It's the code. I recognize that there's the people around it. That's going to cause that. And what you're dealing is it sets up a feedback loop. And that's what you're after. You are after a virtuous cycle. You know, people are happy to work there, and the code does not make them angry with each other. It's just like it's all about getting along. You know, so this idea of increasing the knowledge through sort of code reviews or pair programming. A lot of people think, that sounds very, very slow. Mobbing, all of these, they sound like they're slowing us down. It's like, oh, no, actually, what we're doing is we're increasing the team knowledge, and therefore, ultimately, in the long term, we're speeding up. And that's a different game.
And that's really interesting what you just said there, because whenever we are talking about pair coding, people always say that, oh, yeah, but that's slower than coding alone. But one, I don't think it's much slower. I think that a pair can work much faster in terms of speed as well. But in terms of velocity, that's going in the right direction at the right speed.
That's right.
Probably even a mob can beat people working
exactly,
alone.
Because it's that direction thing. It's that direction, and it's one of those things about being careful with what you measure. And you will get what you measure. So therefore the problem is that when they look at this idea which of like, we're going to increase the number of people, we're going to parallelize the number of people, we've got n developers, therefore we can do things this n times faster. It's a classic division of labor. The problem is that division of labor, that stuff is based on the idea of manufacture. That's not how thought or knowledge work is based. That's not how it works. It's
you can share.
The value increases through sharing. It's not a mutually exclusive thing, and you are building on other people's work. And so therefore how am I going to build on somebody else's work if we don't talk? How am I going to build if they're busy heading off in the wrong direction and I'm busy heading off in the wrong direction, and we both think we're in the right direction? We don't realise that there's this. So there's this idea that we've optimized team structures and organizational structures in many ways around the wrong paradigm, the wrong idea. And so I quote in the talk Alan Kelly, who's speaking here at Craft as well. He often talks about software having diseconomies of scale rather than economies of scale. Software is not a physical thing in the way that a manufacturing process is, and therefore what we're trying to do is say, well, how do we get a group of people? Now, you just doubling the number of people instantly creates more communication paths. It doesn't just double. This is a quadratic thing. So this idea is that will be reflected in time. It will be reflected in code. It will be reflected in the architecture, and this notion of knowledge work has a different kind of formulation. There's a sort of an optimal size. You know, you can do with more than one person, because otherwise that one person is not having a kind of reality check. They've just got their own assumptions, and you need a certain diversity of thinking in the team. But once you get beyond a certain point, then it starts slowing down, because all you're doing is managing communication rather than encouraging the intelligence. You're actually spending your time trying to get the word out to everybody, or isolate people from one another. You just need it to be small enough that that's actually not really an issue. So it seems that it feels like we've optimized for the wrong thing, and that traditional management that ideas are looking understandably from the wrong point of view. They're looking at it through the lens of physical manufacture and construction work and things like that, where actually there is a scaling to be had by putting more people on, and that remains a relatively scalable concept. Whereas in the software, we find it peaks early.
Yeah.
And then what happens after that? Well, we're all busy. We're busy creating stuff, but actually, it's not the right stuff.
Yeah. Okay. Well, thank you for being in the show, and
thank you very much for the drive.
Okay. Thank you. Bye.
Thank you for watching this episode. I hope it earned your subscription. But while you're here, let me show you something. The people behind me are playing a game called Lean Poker. It's a fun and exciting way to learn how you can deliver value much faster than you have ever imagined. It's exciting. The link is in the description. Check it out if you want to support this channel.